Hi, I am Dr. Tindranath Mandal. I am a medicine specialist. Today I will discuss how to determine the cardiac axis. Um, Hope you will enjoy this video lecture of me. And the first of all, if we see what is axis. Actually, if we say that any impulse of the heart will originated from the SA node, then it deploys the right atrium, then left atrium, right ventricle, and left ventricle, and the impulse moves in so many different directions. But whatever it is, its main target is to reach the left ventricle. And if we make a summation of these different movements of this impulse, then we will get an average movements of the impulse that is towards the left ventricle, and this is actually cardiac axis. And we can easily determine the cardiac axis from the ECG, but before we have to understand this photograph. Okay, that is if we see there are 12 leads in ECG and 6 are limb leads, and the limb leads are AVR, AVL, AVF 1, 2, 3. So first of all, we have to know some basic thing, that is these six limb leads looks at the heart from different levels, and that is we can compare these six leads with that of six CC camera. And the location of the camera we have to memorize, because this will help us to determine the axis. If we see the AVR lead is positioned at minus 150 degree, AVL minus 30 degree, lead 1 0 degree, lead 2 plus 60 degree, lead 3 plus 120 degree, and lead AVF at plus 90 degree. And it is very important to know that when an impulse will move from any leads, moves away from the lead, and that particular lead will develop a negative QRS complex. So if we see here, the impulse from the SA node usually always move away from this AVR lead. So in AVR lead there will be all the waves like P, QRS, T, all the waves are negative, because this lead or this camera always thinks that the impulse moves away from me. And if we see the lead AVL 1, 2, AVF 3, and the impulse is moving towards all those leads. But if we see very carefully, the impulse, the majority of the impulse or the summation of the impulse moves close to the lead 2. So what will happen? There will be a positive wave in AVL 1, 2, AVF 3, but the positivity will be more in lead 2. Why? Because the axis or the impulse moves close to the lead 2. So what will be in case of normal cardiac axis? In case of normal cardiac axis, there will be a positive QRS complex in lead 1, positive will be in 2, and also in 3, but the positivity of the QRS complex will be more in lead 2. And how we will determine the QRS complex is positive? Yes, it's very simple. If the R wave of the QRS complex is more than the S, then it is positive, and if the S wave is more than the R height of the R wave, then it is negative QRS complex. And so if we, I think we have learned the basic thing. Now we can see that the normal cardiac axis is in between minus 30 to plus 90 degree, and the left axis deviation is from minus 30 to minus 90 degree, and right axis deviation is in between plus 90 to plus 180 degrees. And here I have tried to show that this is a normal cardiac axis, because in lead 1 there is a positive QRS complex. You can see this is the R wave, and there is a small S wave, so R greater than S, so this is a positive QRS complex. Same here, it is also positive, and positive also in lead 3, but the positivity is more in the lead 2, so we can say that this is normal cardiac axis. Once again I am telling that in normal cardiac axis there will be positive QRS complex in lead 1, 2, and 3, but the positivity will be more in lead 2. And now we can show in this here in this ECG, we can see here the R greater than S, so it's positive, it's also positive, and lead 3 also positive, but this positivity is more than lead 1 and lead 3. So here you can see positive, but more positive in lead 2, so this is normal cardiac axis. And now what will happen in right axis deviation? Okay, if we see the theory, when the right ventricle will be hypertrophied, it will exert more impression on the ECG, and so the axis will be swing on towards the right. Here you can see that if we see that this is the patient is standing in front of me, so this will be his or her right side. So if the axis will be swing to the right, then what will happen? And then there will be negative QRS complex in lead 1, because this lead will feel that the impulse is moving away from me. So lead 1 will be, there will be a negative QRS complex. Lead 2, there may be positive, or in severe right axis deviation it may be negative, and lead 3 there will be definitely positive QRS complex, because this axis is moving towards the right, towards this lead, that is the lead 3. And so what will happen in QRS complex? There will be negative, what I said earlier, and lead 2 there will be definitely QRS negative, and lead 3 there will be positive QRS complex. So in right axis deviation, QRS complex will be negative in lead 1, 2, but will be positive in case of lead 3. I have already told that. Now here in this ECG, if we look at here the R wave is less than the S wave, because this is S, or we can say that S is greater than R, so this is negative QRS complex. Here it's also a negative QRS complex, but in lead 3 it is positive QRS complex. So this is right axis deviation. I think you have understand, because this is very easy to understand. I am not interested to tell the causes of the right axis deviation. And now what will happen if there is left axis deviation? In left axis deviation, usually particularly it occurs when there is left ventricular hypertrophy, and there are so many causes. But if I see this photograph once again, if this axis moves towards the left, and then what will happen? Then in lead 3, lead 3 will thinks that the impulse is moving away from me, so there will be a negative QRS complex. In lead 2 there will be also a negative QRS complex. Lead 1, as it moves towards the air, there will be a positive QRS complex. And so in left axis deviation, there will be a negative QRS complex in lead 3, lead 2, and positive QRS complex lead 1. But if we see very carefully, that we can say only left axis deviation if it is beyond AVL, because left axis deviation is in between -30 to -90 degrees. So this axis should move beyond AVL. So there will be a positive QRS complex also in AVL, but the positivity will be more in AVL than 1, because these axes have to move beyond AVL. So we can say that in left axis deviation there will be QRS negative in lead 3, lead 2, positive QRS complex in lead 1 and AVL, and the positivity will be more in AVL than 1. Here in this ECG, what we will see, that here it is a positive QRS complex, lead 2 leads to its negative QRS complex, lead 3 negative QRS complex. In AVL there is positive QRS complex, and if you see that the positivity is more in AVL than lead 1, so it's left axis deviation. So I think this is very easy if we understand the basic of the ECG, particularly the position of the 6 limb leads, its location, and the 2 or 3 basic principles, that when an impulse is moving away from any lead, in that lead there will be a negative QRS complex or negative wave, and when an impulse is moving towards any lead, in that lead there will be produced positive deflections or positive waves or positive QRS complex. And I think you hope you enjoy the videos. Thank you very much. I will try to make another video soon. Thank you very much.